There we go. All right. So yes, I'm not Abby Rymer, but I am a member, an associate member of the Neptune Odyssey PMCS team, and so what I'm here to talk about. Unfortunately, Abby, when she made this presentation, put a bunch of wonderful quotes that I'm simply going to read many of and then extemporize for additional commentary. On the Neptune Odyssey team, I'm a member of primarily the Triton observation group, Triton landed science and orbital science. So we may be a little Tritonocentric on this talk as well. But not to take any spotlight away from Neptune itself, which is the star of the show and one of the most and the most relevant component of this as far as exoplanets is concerned, because Neptune and the idea of exoplanets in our backyard and exoplanets next door came multiply from solar system people, including Stephen and Abby, who started really thinking about these particular worlds, the blue worlds and the yellow world as the most accessible exoplanets. So to begin and think about Neptune, one of the cool things about the Neptune system is that Neptune itself may be more pristine, and that's debatable, but than Uranus. Depends on when and how everything started up when the planets were accreting. But one thing that's certain about the Neptune system is that its moon and ring system is not the most pristine. And the quote from New Scientist: "Neptune's moons were normal until Triton came crashing in," which is part of what makes the Neptune system so appealing to explore. So our fearless leader has said there's only one planet type left to orbit an ice giant. So this is, and this is true, right? And so our proposal, the Odyssey proposal, proposes that NASA continue their voyage of excellence in planetary exploration and leadership by scheduling a flagship class mission to the Neptune-Triton system. And the idea of a flagship to the outer solar system is one of the points of a flagship mission also, is that it has to be an excellent mission for science, but it also has to inspire and excite. That's the purpose, or that's the need, an additional need of any flagship, and this, I think, is one that could well do it. So the one of the things that has happened among the outer planetary science community, it used to be until through the last decadal that the Uranus orbiter and probe was the priority. And relatively recent discussions and in OPAG have shifted the ground a little bit to support a Neptune flagship mission over a Uranus mission, in part because, or maybe largely because of the success of the New Frontiers mission at Pluto and Charon and going out into the Kuiper Belt. The fact that Triton is also a captured dwarf planet and a high priority ocean world target kind of tips the balance a little bit, because the ability to go to Neptune and look at that system and an ocean world and a dwarf planet all at once is part of what makes it super compelling. So a little bit of the history. It takes a village to do an outer planet mission, and the history of ice giant explorers and the proposals for them and the desire to do them has been long-standing. So there have been a series of white papers. The ice giants as exoplanets in our backyard is a white paper from the Exoplanetary Science Strategy in 2018. And exploration of the outer system has been, a theme that we've been pushing for a very long time. And so this study is essentially one of the culminations of that. And again, going to the current decadal, if we take a look at the large class missions in priority order, what we have is, we have the Mars Astrobiology Explorer, which one could argue is Mars 2020. We have Jupiter Europa Orbiter, and one could argue this is Europa Clipper. And now we have, in Visions and Voyages, we had the Uranus Orbiter and Probe, and with the shifting priority, this could be, clearly two of the three. We've checked off the boxes, and so the next box to check, Neptune-Triton. And this is a little bit wordy, but it gives me the chance to sort of remind myself of all the stuff that ODYSSEY is planning on doing. Fortunately, Marty gave us the best background about what these studies are for and the history of the decadal and what we're feeding into. But the idea that the Neptune mission is it's a systems mission. If you imagine, one of our candidate architectures, right, what we're modeling, what we're thinking about to guide us is essentially sort of like Cassini-Huygens mission to Saturn. So we're talking about a large planetary system that needs to be explored in that way, right? So we have an ice giant orbiter and probe. We're targeting the multiple decadal priorities, comparative planetology of the Kuiper belt. We're looking at dwarf planets at the same time, dwarf planets, ocean worlds, and these sort of evolved or are messed with moon system, and for the giant planet itself, this is an interesting red view of the blue planet, Neptune in the IR. So what we need to study for Neptune is structure and characteristics of the dynamo and the overall interior, the bulk composition, and all of the stuff that we're thinking about for Neptune, getting into Neptune, thinking about its magnetic field, and getting deep enough down that we can begin to put together what an ice giant's interior is like, which is of course direct feed into how we can think about ice giants, both cold and hot, for the exoplanets as well. And again, sort of the laundry list of things that you would need to do in a system like the spectroscopy, visible imager for both the giant itself and the moons and the rings, ions and electrons, and ion spectroscopy and dust analysis. So again, system science for this planet. The development of the mission, we have a bunch of sub teams, and which I'll get into in a moment. And we're doing all the trades of how we get to Neptune, how we navigate the system. And again, just if those of you who have been involved with or seen Cassini, the tour of the system is crazy, right? And since Triton is not exactly on the ecliptic plane or on the equatorial plane of Neptune, so getting to Triton is also not particularly easy. So we gotta do all kinds of wonderful mission ops in order to navigate this system. And this is not something you can do it's hard to operate out there even on a New Frontiers class if you're not just flying by. If you want to go to the system itself and do anything serious, you need this flagship. So a little bit more sort of history of this of the work. There were, of the 54 PMCS proposals, 7 of them were for ice giants, and really it was the Triton element that had this particular study stand above the rest. To one of the favorite quotes of the team, I think, is that this mission is literally a flagship for everyone. And I think I'll include the Exoplanet community for this because of the depth of science for the ice giant planet itself. So here are the various teams. It's a large team, unsurprisingly, because we have a large system to explore. For the planet itself, for the planetary environment, for the icy satellites and rings, Triton, and an entire subgroup that deals with sort of the exoplanetary applications as well. And this is with the knowledge that it is a long duration mission, out to the outer solar system. We are also including sort of one of these the ability to study not just the mission, but to study the mission team as well as things go on. Because in order to get out there, it's going to take 10, 15 years to do that, and the mission is going to be multiple years long. So we're talking about a multi-generational mission. Any mission to the outer system is a multi-generational mission, and you have to maintain continuity of team and continuity of interest, and keeping and ramping up the information that you're sending out as you go. I'm not going to spend too much time on this. Strengths, pat ourselves on the back. That's great, but the idea that this is a flagship for everyone, and that there isn't a piece of the science community that doesn't have a stake in this game, and that that the Triton adds the sort of combines planetary, solid bodies, atmospheres, exoplanets to the whole thing. So, but I will spend a little bit more time talking about what they thought the weaknesses of this proposal were, because this is also a sort of a capability thing. So the first question is, so we pitched the proposal as being basically shovel ready. We're ready to do this. We're ready to actually go build this thing, as soon as we get the go ahead for a flagship. But the question is, can we really be ready by 2030? And the answer is yes, actually. We actually have the technology, and we actually have the capability of getting all this stuff ready. And 2030, that's to take advantage of the last Jupiter gravitational assist for the next 14 or so years. So it really is kind of 2029 to 2031 iffy, or not until the 40s. So to get to Neptune. So the timing is a consideration. We in our proposal, we actually ditched a trade study for something a little bit more complex at Triton, and they actually encouraged us to analyze the risk, which was Abby's favorite weakness, because it gave us the excuse to spend a little bit more time thinking about what we could do at Triton. And that sort of gives me one of my favorite things to talk about, which is the idea of a more complex, more capable Triton lander, which, and this is a concept being explored by NIAC with Glenn Research Center, which is in fact this is kind of a discovery class lander. So it may not be this, but we are at least thinking about the advanced capabilities of something like this, where the Triton hopper is in fact something that lands on the surface of Triton, harvests the nitrogen, snow, and ice from the surface, uses it as propellant, and allows itself to propel, sort of dragonfly-like, but without the propellers. Instead, we have thrusters from place to place on Triton. And the idea of this would be to go multiple places, potentially even from pole to equator, on a planet that actually has active geysers and varying geologic terrain and weather and stuff like that. So this concept is, again, maybe a little bit too big for the Neptune ODYSSEY, but it is, and so we may end up with something a little bit, single point version of this, or even a Huygens, more like a Huygens thing. But the idea but this trade is something that's going on for Triton, and allowing us to get potentially much deeper science of an ice/ocean world. And again, just the concepts of the hopper would have a multi-week sojourn at any given spot, hop to the next place. We could actually get baselines of internal features as well, depending on the instrumentation we could have. So this is, again, some of the trade-offs we're working on as far as Triton is concerned. But another aspect of this is, the journey out to Neptune takes a long time, and you're sending a very capable spacecraft with lots of great instruments out to Neptune, and you might be flying by Jupiter. It depends on what rocket you've got, whether you've got the SLS or something else, whether you can go direct or have to do a flyby. We will be doing science on the way out, and we all know how advantageous, how useful things like the Cassini flybys were on the way to Saturn, and the New Horizons flybys on the way out to Pluto. That's going to happen again using ODYSSEY. But the idea as well, if you're going out as far as Neptune and you have a chance to look back into the solar system, Giada earlier was showing us the pale blue dot image of Earth from Voyager. Imagine taking something a little bit more capable and looking back more constantly as you fly away, and take pale blue dot and pale yellow dot and pale red dot images as you fly out towards Neptune. And the further you go, the more you get. Over 10 years, you're going to spend, or 15 years, you're going to spend a great deal of this outside the orbit of Jupiter. So imagine an entire inner and middle solar system movie of our planets treated as an exosystem, right? So it doesn't happen, we'll get phase curves, we get just the view of what it will be like, a system just like ours, because it is ours, from an exoplanetary perspective. So the idea of going out this far and looking back before we look forward is, I think, not just a super way of getting the public and the layperson involved in this kind of exploration as well as tying in the exoplanetary science directly to the planetary science. So websites in preparation, and there will be more, of course, and Marty was saying also the PMCS groups are going to be presenting at and for LPSC. So somebody who will be better informed about all the details of the mission will be giving that talk. So I hope that you can all make it to LPSC and see the reports as they come out. And we have our key milestones. We have a study at APL, just like very similarly to the fact that the Venus mission has a study at Goddard. So that's our timeline for all this stuff. And I'm just going to leave this up here and say thanks. And these are sort of Abby's final musings of ice giants and the planetary mission studies. And we're really excited about it. I mean, everybody got a little bit of a late start, but we'd be, there's so much that we need to do for these studies, so much we need to be able to accomplish. Even if we got an early start, we'd still be worried about that we won't be able to get it all done, but we will. So we're all excited to have a chance to do this, and the support of the community has been great, and we hope to deliver a very cool flagship mission concept for you.